Okay, so it's the same thing that we went through. So here I have 6 matrices A1 through A6. So as I said in an assignment, this is what I would have given to you, just this part, not the individual matrix dimension. So I would have given the chain length A1, A2 up to A6 and the P values, P0, P1, P2, P3, P6. So if you're just given this, you should be able to start and do the problem. So A1 is going to be of dimension P0 times P1. A2 is going to have dimension P1 times P2, A3 is P2 times P3, A4 is P3 times P4. So for any matrix AI, its dimension is 1 less than I. So for AI, it's going to be Pi minus 1 times Pi. That is the dimension of that matrix. So the last matrix A6 is P5 by P6. That's the dimension. Alright, so that's how you get the dimensions of the individual matrices. So you have to set the K M table and K table. So this is how you set them. So it's a 6 matrix here. So I equals 1, 2, 3 up to 6. J equals 1, 2, 3 up to 6. And then so when I equals 1 and J, we don't do any multiplication. So that's why it's M of I comma J is 0 for I equals J. And actually you should have recorded as null. The K value is null, but K can be only from 1 to 6, so it's okay to record it as 0. That's okay. Alright, so now we'll start with spread of 1. So spread of 1 means I is less than J. So again, the spread of 1 means again the difference between I and J is 1. So which means you're going to fill these cells, I equals 1, J equals 2, this cell. Then I equals 2, J equals 3, I is 3, J is 4. So you're going to fill these cells with the difference between I and J of 1. That's what I mean by spread of 1. Alright, and the corresponding K table. So according to our recurrence, so let us do, if M of I comma J, so I is 1, J is 2, so K can be only 1 value, and in this case K is also 1. So it is M of 1 comma 1, then plus K plus 1 comma J, so M of 2 comma 2 plus Pi minus 1 times Pk times Pj, so it is Pi minus 1, so I is 1, so it's P0 times P1, which is K is 1, and then P2 for J. So all these are from the diagonal cells, because this is spread of 1, so these sub problems come from the earlier iteration, so they're all the diagonal cells. So this is 0, M of 2 comma 2 is also 0, so P0 P1 times P2 is 4 times 10 times 3, so that is 120. So there's only one K value, so that itself is a minimum. So 120 is the minimum of multiplications from 1 comma 2, and K is 1. Similarly, M of 2 comma 3, K is 2, because between 2 and 3, I and J, K can take only value of 2. So we do fill up the recurrence. Okay, so it is 360 multiplications for K equals 2, and 720, K is 3, 1680, K is 4, and so on. Okay, I hope you can do that now. Just substitute, so you fix I and J and just change the K values, and here there's only one K value for each case, and just plug in the K value and come up with the row and column IDs, and just pick up the numbers from the cells from the M table. Now for spread of 2, we have two possible K values for each case. So M of I comma J, let's say M of 1 comma 3 means K can be either 1 or 2. So if K is 1, the recurrence is M of I comma J plus M of K plus 1 comma J plus Pi minus 1 times Pk times Pj. So 1 comma 1. Okay, so here I equals K, and then plus K plus 1 comma J, so M of 2 comma 3 plus Pi minus 1, so P0 times Pj is 3 and K is 1, so P1. So plug in the numbers, you get 840 for K is 1. Then K is 2, M of I comma K, so 1 comma 2 plus m of k plus 1 comma j, which is 3 comma 3, plus pi minus 1, which is p0. So you see p0 and p3 are fixed. Just plug in the k value. So p1 for k is 1, so now k2, so it's p2. So m of 1 comma 2 is 120 from the table, and 3 comma 3, m of 3 comma 3 is 0 because that's the diagonal cell, I equals j case, and then 4 times 3 times 2, which is the dimensions of this p0, p2, p3. So you get 264 for k equals 2. So that's the minimum between 840 and 264. So record 264 here for m of 1 comma 3, and the k value is 2. Similarly for m of 2 comma 4, the k values can be 2 or 3. Then accordingly find the number of multiplications. So I comma k plus 1 comma j, then this pi minus 1 times pj times pk. So you get 1320 for k equals 2 as minimum. So record 1320 here for m of 2 comma 4, and the corresponding cell in the k table is 2. So do the math like that and find out the m values for m of I comma j with spread of 2. Okay. So always write down the recurrence and substitute the different values of k once you fix your I and j. Then spread of 3 means I and j differ by 3. So k values, you can have 3 different k values. So m of I comma j, m of 1 comma 4, k can be 1, 2 or 3. Accordingly write the recurrence. I comma k, m of k plus 1 comma j, then pi minus 1 pj times pk. Then in this case you get 1080 for k equals 2. So you may wonder, what if there's a tie? So let us say I get for 2 k values the same minimum value, 1080. You could break the tie in any order, doesn't matter. Okay, so most of the cases you don't get it, but in case you get a tie, just pick one k value and record that here. Okay, so you could pick any k value for a tie. So you do all these things, and then finally for spread of phi, you get something like this. So m of I comma j with I equals 1, j equals 6. You have 5 different k values, k equals 1, 2, 3, 4 and 5. And as I said, this is more easy to visualize. So m of I comma k, so 1 comma 1 for k equals 1, then k plus 1 means m of 2 comma 6, then pi minus 1, so p0 times pj is p6, then k equals 1, so it's p1. Then if k equals 2, it's m of 1 comma 2, then plus m of k plus 1, so 3 comma 6. Then p0, p6 are fixed, only thing is k equals 2, so p2. Then m of 1 comma 3, m of k plus 1, so 4 comma 6, then p3. So that's how you can generalize the recurrence, and you get the minimum here is 1736 for k equals 5. So that's the overall answer you want, 1736 multiplications to multiply from a1 through a6. So now we have to work out the parenthesing part. So for a1 to a6, the k table says 5. So that means we have to split at 5. So this is how we split it. A1 through A6 split at 5. So multiply A1, A2 up to A5. That's one subchain. And whatever the result of that multiplication is, multiply with A6. That's how you should split it according to our K table. Now you have a subchain of length more than 2, A1 through A5. We need to know how to split that further. So A1 through A5, the table says split at 2. A1 through A5 means I equals 1, j equals 5. The K table says split at 2. So that means you have to split A1 through A5 at 2. So A1, A2 is one subchain, then A3, A4, A5 is another subchain. Now this is a subchain of length more than 2, so we need to know how to split this further. So A3, A4, A5. So look at A3 to A5. we have split at 4. So that means we have to split A3, A4 as one subchain and then A5. So this is how you should multiply them. Now you can cross check to make sure everything is right. So first you have to do what? A1, A2. So or A3, A4, you can do it independently. So A1, A2 is going to be like what? A1 is 4 by 10 matrix. A2 is a 10 by 3 matrix. So it's going to be 4 times 10 times 3 multiplications, which is 120. The dimension of A1 by A2, that matrix is 4 by 3 matrix. Then A3, A4 is 3 by 12 times 20. So it's 3 times 12 times 20. That's going to be 720 multiplications, and it's a 3 by 20 matrix. Then what you do? You multiply this A1, A2 with we multiply A3, A4 with A5. That's the first thing you have to do, because it's splitting A3 to A5 like this, right? So multiply A3, A4, the product that we just got, with A5. So A3, A4 is a 3 by 20 matrix. A5 is a 20 by 7 matrix. So when you multiply, it's going to be 3 times 20 times 7, which is 420 multiplications. And the product is a 3 by 7 matrix. Then we multiply A1, A2 with this A3, A4, A5. So A1, A2 is a 4 by 3 matrix. Then A3, A4, A5 is a 3 by 7 matrix. So it's 4 times 3 times 7, which is 84 multiplications with the dimension 4 by 7 matrix. Then you multiply this subchain with A6. So A6 is a 7 by 14 matrix. 4 by 7 times 7 by 14. So this is the number of multiplications, and the final dimension is 4 by 14. So we have to add all these multiplications we encountered for the subchains, and that will add up to 1736. And you can cross check, that should be same as the 1736 you got. Okay. So for assignment, you may wonder, do you have to do all these things on paper? I'll give it a choice. So you can do everything in paper like what I have just shown, and scan or type it up neatly like in a Word document and type submit as a PDF file, or you can program this. So I have given you the recursion. So if you want to do a programming based assignment on this, it's up to you. So you can do a programming, and so I stop my sharing. So you can